In this video, I would like to look at congruent triangles and how we prove them. Congruent triangles are identical. If two triangles are congruent, they are the same shape and the same size. Let's quickly sketch a triangle down here, and we can call it A, B, C. Now let's make a copy of triangle ABC, and we can put it on the right-hand side of the page. Let's call this triangle PQR. It does not matter if we turn the triangle around or flip it upside down. It will still be identical to triangle ABC. Just like similar triangles, if two triangles are congruent, then corresponding internal angles will be equal. Let's write ABC for the triangle on the left and PQR for the triangle on the right. A is the first letter in ABC and P is the first letter in PQR. So angle A will be equal to the corresponding angle P. Let's mark A and P on our diagrams in red. B is the second letter in ABC and Q is the second letter in PQR. So angle B will be equal to corresponding angle Q. Let's mark angle B and angle Q in green. Finally, C is the last letter in ABC and R is the last letter in PQR. So angle C will be equal to the corresponding angle R. Let's mark angle C and angle R in purple. But unlike similar triangles, if two triangles are congruent, then corresponding sides are equal as well. A and B are the first two letters in ABC. P and Q are the first two letters in PQR. So AB will be equal to the corresponding side PQ. Let's mark these sides in red. B and C are the second and third letters in ABC. Q and R are the second and third letters in PQR. So BC will be equal to the corresponding side QR. Let's mark these sides in green. Finally, in ABC, A is the first letter and C is the last. In PQR, P is the first letter and R is the last. So we can see that AC will be equal to the corresponding side PR. So now we can mark these sides in purple. When working with congruent triangles, we use this symbol. It looks like an equal sign with an extra line. These two triangles are congruent, so we can say triangle ABC is congruent to triangle PQR. Some students get confused between the symbol for congruency and the symbol for similarity. Let's quickly sketch it up here. Remember that congruent triangles have equal sides, so the symbol looks like an equal sign with an additional line. Similar triangles do not have equal signs, so the symbol is flipped on its side. Congruent triangles have 3 pairs of equal angles and 3 pairs of equal sides. Of these 6 features, to prove congruent triangles, we only need to prove 3 equal pairs. And there are 4 different ways that we can do this. We can prove 3 pairs of equal sides, 2 pairs of equal angles and 1 pair of equal sides, 2 pairs of equal sides and 1 pair of equal angles, or the right angle, the hypotenuse, and the side. Before we look at this in more detail, please remember that we cannot use 3 pairs of equal angles to prove congruency. We use equal angles to prove that triangles are similar, and we know that triangles that are the same shape may not necessarily be the same size. Let's look at the different ways we can prove congruent triangles. Let's start with 3 equal sides, which we refer to as side, side, side. To use this method, we need to prove that all 3 corresponding sides are equal. Let's put in our 2 triangles, ABC and PQR. A and B are the first two letters in ABC. P and Q are the first two letters in PQR. So AB must be equal to the corresponding side PQ. Let's mark these sides in our triangles in red. B and C are the second and third letters in ABC. Q and R are the second and third letters in PQR. So BC must be equal to the corresponding side QR. Let's mark these sides on our diagram in green. Finally, in ABC, A is the first letter and C is the third. In PQR, P is the first letter and R is the third. So AC must be equal to corresponding side PR. Let's mark these sides on our triangles in purple. And now that we've proven that 3 pairs of corresponding sides are equal, we can say triangle ABC is congruent to triangle PQR. We've used 3 equal sides to prove this. So as our reason, we say SSS for side, side, side. Next, I would like to look at 2 sides and an angle, which we refer to as side, angle, side. To use this method, we need to prove that 2 pairs of corresponding sides and the included angle are equal. Let's draw in triangle ABC and triangle PQR. For side, 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 we had to prove that all 3 corresponding sides were equal. In this case, we can prove any 2 sides. So let's say that AB is equal to corresponding side PQ. Let's mark these sides on our triangles in red. Let's also say that AC is equal to corresponding side PR. We can mark these corresponding sides on our triangles in purple. The most important part of this method is that we have to prove that the corresponding pair of included angles are equal as well. The included angle is at the vertex between the 2 sides we have just used. In triangle ABC, we have just used side AB and side AC. So angle A is the included angle. And we can mark this angle in red. In triangle PQR, we have just used sides PQ and PR. So angle P is the included angle. Let's mark this angle in red as well. To use this method, we need to prove that angle A is equal to angle P. If we can prove that 2 pairs of corresponding sides and the corresponding included angles are equal, we can say that triangle ABC is congruent to triangle PQR. And as our reason, we say SAS for side, angle, side. To use this as our reason, we have to write it as SAS because the angle is included. Let's make some space and look at our 2 triangles again. Let's say that AB is equal to PQ, and we can mark these sides in red. And again, let's say that AC is equal to PR. We can mark these sides in purple. But now, let's say we find that angle C is equal to corresponding angle R. Let's mark these angles on our diagram in purple. Again, we have 2 pairs of corresponding sides that are equal, and we have 1 pair of corresponding angles that we found to be equal to. But angle C is not the included angle in triangle ABC between AB and AC. And angle R is not the included angle in triangle PQR between PQ and PR. So we cannot use side, angle, side as a reason, and therefore we cannot prove that these 2 triangles are congruent. Next, I'd like to look at angle, angle, side. To use this method, we have to prove that two pairs of corresponding angles and one pair of corresponding sides are equal. When we used side angle side, we had to use the included angle. But when we use angle angle side, the side we are considering does not have to sit between the two angles. We can use any two angles in the triangle and any side. So let's draw in triangle ABC and triangle PQR. Let's say that angle B is equal to corresponding angle Q. Let's mark these angles in green. Let's say that angle C is equal to corresponding angle R, and we can mark these angles down in purple. Now we can consider any pair of corresponding sides. So let's say that AB is equal to corresponding side PQ, and we can mark these on our diagrams in red. Now we have two pairs of corresponding angles that are equal and one pair of corresponding sides. So we can say the triangle ABC is congruent to triangle PQR because of two angles and a side. And we write this as AAS. Finally, I'd like to look at our last reason, right angle hypotenuse side. This method only works with right angle triangles. To use it, we have to show that there is a corresponding pair of right angles in both triangles. Then we need to prove that the hypotenuse and one other side is equal in both triangles as well. To better explain this, let's draw in triangle ABC as a right angle triangle and triangle PQR as well. Straight away, we can see from the triangles that angle B and its corresponding angle Q are both right angles. So we know that angle B is equal to angle Q. Next, we have to prove that AC, the hypotenuse of triangle ABC, is equal to PR, the hypotenuse of triangle PQR. So let's mark these corresponding sides in purple. Then we can use any other side. So in this case, let's say that AB is equal to its corresponding side PQ, and we can mark these sides in our triangles in green. Now we have the right angle, the hypotenuse, and one other side. So we can say that triangle ABC is congruent to triangle PQR. And as our reason, we say RHS for right angle hypotenuse side. Let's make some space and quickly look at our right angle triangles again. We can see that angle B is equal to corresponding angle Q. And let's say that AB is equal to the corresponding side PQ. Let's mark these sides in red. Now let's say that we cannot prove that the hypotenuse AC is equal to hypotenuse PR, but we can prove that side BC is equal to corresponding side QR. So let's mark these sides in our diagrams in green. In order to use RHS as a possible reason, we have to show the hypotenuse in each triangle is equal. Without the hypotenuse, we cannot use this method. But let's look at what we do have. We know that side AB is equal to corresponding side PQ. And we know that side BC is equal to corresponding side QR. We can also see that in triangle ABC, the included angle over here at B sits between AB and BC. And in triangle PQR, the included angle at Q sits between PQ and QR. Angle B is equal to angle Q because these are both 90-degree angles. So now we have proven that two pairs of corresponding sides are equal, as well as one pair of corresponding included angles. So even though we don't have the hypotenuse, we have still found that triangle ABC is congruent to triangle PQR because of side, angle, side.